In this video, we'll show how to solve differential equations using the method of undetermined coefficients. Keep in mind that this method is limited to second linear differential equations with constant coefficients, and the non-homogeneous part only includes three functions: polynomial, exponential, sine or cosine functions. In this case, we are representing the third case of this method, the case when you see sine and cosine functions appears in the non-homogeneous part. First, we want to get the undetermined coefficient form for the non-homogeneous part in this case, so we called it big Y of t. And we always start with t to the s. S is an unknown value which is to determine, and then it's multiplied by a series of functions that matches with the non-homogeneous part. Polynomial, exponential, sine, and keep in mind that even though in your non-homogeneous part you only see one function sine or cosine, but in your undetermined coefficient form you need to include both, right? You can see that you have polynomial functions first, and then exponential function, and then sine, and you add to another polynomial function, exponential function, and cosine. So you always have to include both sine and cosine along with exponential function and polynomial functions. And then the next step is to determine the value of s by using the characteristic polynomials, and then solve for the roots of this polynomial using quadratic formula. In this case, if the roots are complex and the roots are the same as alpha plus or minus beta I, where alpha is the coefficients of the exponential functions and beta is a coefficients of t of the sine or cosine functions. If these two conditions are true, then s equals to 1. In any other cases, s should be equals to 0. Alright, and then once you find form for big Y of t, you can find y prime, y double prime. You can plug y double prime, y prime into the original equations, and then you combine all the like terms to match with the other functions in the non-homogeneous part. And then you can solve all the unknown coefficients to find the solution to the non-homogeneous big Y of t. Once you have the big Y of t, you can find the homogeneous solutions, and then you can combine homogeneous solutions and the non-homogeneous solutions to get the general solution to the differential equation. Alright, let's take a look at an example. So here an example of second differential equation with constant coefficients, and the non-homogeneous part includes, exponential functions, cosine, and another functions of sine. We can see that there's two functions on the right side. We call the first functions is g of t, and the second function is h of t. We want to explore the forms for g of t and h of t. This is the reminder, this is the general form for the third case. Okay, for g of t, we found that alpha equals to 1, beta equals to 2, so then we can form the undetermined coefficients solutions for g of t. I called it y1 of t as this form. So we always start with t to the s, I have e to the t because alpha equals to 1, and sine a is a unknown coefficients of sine of 2t, right? You get from cosine of 2t, and do not forget to add b times cosine of 2t. In this case, I factor the e to the t out to make the forms a little shorter. As you can see that in the general form. You have e to the alpha t is a common term. You can factor it out. All right, that's for g of t. How about for h of t? Alpha equals 0 because there's no exponential functions. Coefficients of t in the sine is 2, so beta equals to 2. So then the y2t, right, the undetermined coefficient form of h of t is of this form. You can see that I use A, B, C, D. It's different notations for all these unknown coefficients. So then to make sure that these functions are different from each other. All right, so the first step is to form the characteristic polynomial using the left side of the equations. Solve for r, and r in this case is the root of this characteristic polynomial are real roots, meaning that, keep in mind, if you look at the third case and the root of the polynomial, characteristic polynomials are real, meaning that the value of s is going to be 0. You only consider the value of s equals to 1 when the real root are complex and it has to match the alpha and beta. But the first condition is already violated, meaning that we know that the value of s should be 0. And let's go through all the steps to make sure that we have the right idea. This is the form, and you ask, does r equals to 1 plus or minus 2y, right? Alpha plus beta I? No. Then s equals to 0. Okay. S equals to 0, then the form y1t should be in this form. Okay. Well, for g of s, for the next function h of t, again ask the same question, r equals to 0 plus or minus 2i, alpha plus minus beta I. Again, the answer is no, s equals to 0, then big Y of t is of this form. When t to the s, when s equals to 0, then t's disappeared. So the solution to the non-homogeneous part should be the combinations of big y1 of t and big y2 of t. Just combine the two together. Now we establish the undetermined coefficient form of the non-homogeneous part. Okay. Big Y of t. Step 3 is you want to find y prime and y double prime. You use knowledge of finding the derivative. You can find y prime, and I found y prime, and I combine like terms in terms of exponential functions, sine, cosine, or just cosine and sine. And I found y double prime, which is the derivative of y prime. And again, to match with the non-homogeneous part, I combine like terms. I just get exponential function with sine, cosine, and a function with just cosine and sine. And step number 4 is you plug y prime, and y double prime into the original equations. I found big Y prime, big Y double prime, plug into the left side, right? The left-hand side of the equation here. And the left-hand side will give me this expression, okay? And again, I combine like terms, so then, we have e to the t, sine, cosine, or just sine, cosine with unknown coefficients. Now we look at the right side. The right side, first part, the right side, we have e to the t, cosine 2t, negative 8 as the coefficients. Then we're going to match this with this part of the left side. That will give us, and then you have sine of 2t here. It will match with this part of the left side. Okay, and you can see that So the coefficients of this part has to be equals to negative a, and the coefficients of this part has to be equals to 1. And since we don't have any functions on the right side that matches to this sine 2t e to the t, then this coefficient here has to be 0. Similarly, we don't have any cosine functions in the non-homogeneous part, so this coefficient here has to be equals to 0. So the next step is to solve for undetermined coefficients to find the exact function big Y of t. From the previous slide, we formed these two equations, which forms a linear of a system of two linear equations with two variables a and b, and we can solve for a and b. Similarly, we form these two equations involved c and d, and then we can solve for c and d. Once a, b, c, d are determined, we can establish a solution to the non-homogeneous part. We could just plug a into a spot, b, c, and d. Alright, once we found the solution to the non-homogeneous part, maybe we would like to check whether the solution that we found earlier is the correct solution. So we can plot the solutions which give us the red curve right here, right? And we can plot the left side of the differential equations using f double prime minus 3f prime minus 4f, and to get that blue curve, which is the representation for the left side of the equation. And now we can plot the right side of the equations, which is going to give us like the green curve right here. And you can see that the blue curve disappeared, which is because the green curve is on the top of the blue curve. That means the two curves are the same, they form the same functions, which shows us that the functions that we found earlier for the non-homogeneous part is a correct solution. The next step is to find the homogeneous solutions, and as a reminder that the roots are 4 and -1, then the homogeneous solutions will be of this form, just includes exponential functions. And then the last step is finding the general solutions by combining the homogeneous solutions and the solution to the non-homogeneous part. Very simple, just combine the two solutions together to get your general solutions to the differential equation. Alright, here you go. Method of undetermined coefficients for the third case.